In this example, we are asked to determine the intervals on which the function is strictly increasing, decreasing, or constant. And we want to be sure to write our final answers in interval notation. So with this type of question, we always want to begin by simply observing the graph that's provided. Now, as always, make sure that you read the graph from the left-hand side to the right-hand side. So for the first case, let's think about where is this function constant? So going over to our graph, we can see that our function is constant between these 2 points. So using our scale, we have each tick mark is a unit length of 1. So this function is constant from -5 to -3. And then we can see that it's constant again over in quadrant 1 between the x values of 1 and 3. So we have 2 intervals here where the function is constant. From our graph, we can see that this function is constant when x is an element of the interval between -5 and -3, and then again in the interval from 1 to 3. Next, we want to think about where is this function decreasing? Again, coming over to our graph, again, imagine yourself walking along this graph from left-hand side to the right-hand side. So we can see that the function is decreasing between the x values of -1 and +1. Again, moving along the graph from the left to the right, we can see that the function is again decreasing between the x values of +3 and 5. So we have 2 intervals where this function is decreasing. So we can say that our function is decreasing when x is an element of the interval from -1 to +1, and then again between 3 and 5. Now, last but certainly not least, we want to think about where is this function increasing? So stepping back over to our graph, we can see there's only one section on our graph that remains between these endpoints here. And again, dropping from the graph to the x-axis, we can see that the function is increasing between the x values of -3 and -1. So we can conclude that our function is increasing in one interval from -3 to -1.